Hello everyone, really happy Ganesh Chaturthi to you all. Not feeling like the face cam today, so it's off. But with or without the face cam, it doesn't actually matter because we're going to start our Python journey. Mm, just give me a second so that I can do some stuff, set it up better so that you can easily. So today we are going to study about OOPS, which is oriented programming, which is a really important concept. I mean, one of the most important concepts, if I would say, um, in basic Python, obviously, not in data science or anything, but this is a concept that you are going to stick around for a very long time. Mm, that being said, let's begin. Mm, yeah, let's begin with this concepts. Object-oriented oriented programming. So basically, initially we have to understand two concepts. What is object and what is, what is an object, what is a class, and why object-oriented programming is needed for us, right? So basically, let me just discuss the needs. Object-oriented programming offers a better way for us to write functional pieces of code, write large pieces of functional code and work with them better in layman's language, right? So instead of having a big chunk of code, Oops helps us break it down into small, better chunks. I mean, small workable chunks, and so that when we're later working on it, it's better to work on, right? Uh, two most im- two prerequisites, or I would say two initial things to know in OOPS are classes and objects, right? So if you remember, I said during the what they call it during our data type session that everything in Python is an object. But what is an object? Like, is it like a daily object, or what exactly do I mean by everything in Python is an object? Hopefully the screen, yeah, screen is visible. Let me just check once again to be sure that screen is actually visible because I don't want OBS messing things up again. Mm, mm. Yep, screen is visible. Better. Just hide this thing. We'll also hide this thing. Okay. Classes and objects, right? Uh, so let me just explain it in easier ways. An object is something that has some values and some methods. So remember strings, remember numbers. They were all objects, right? They had some values, they had some methods. Then what is a class? So class is something that a class is basically something that has the blueprint of an object. Blueprint of an object. So what we do is we generally, I'll show you, we generally define a variable and some methods in a class, and then we take an object, we assign that class to that object, and then we work on it. So imagine how hard it would be if we had to, imagine fractions. If we had to generate fractions one by one, we had to, generate a single fraction, then get another fraction. It would be very hard. But using the fraction class, we just generate the fraction. We know what things to be done on the fraction, like finding the LCM of a fraction or finding the HCF between two fraction, or just getting, the basic stuffs in a fraction, like the simplest form of a fraction, which is basically dividing them with their common divisor until they have their root form, or turning a fraction to a decimal, or turning from a decimal to a fraction. Those all functions are done on a fraction. So fraction can be considered a class. So a object from fraction will be 1 by 4. So 1 by 4 is a fraction and it's an object. It's an instance of that particular class, and it has a value. It has some functions, methods defined for it. Okay. So this is basically what a class and an object is. I'll just show you how to really get a feel for it with a better definition. Let me see if I can find for you. Let me check my previous notes. If I can find a better definition, I will just also tell that so that maybe I will write that too if I find a better definition. Also, why we do need to create a class? Because Python has so many already existing libraries, already existing classes. So need for creating a class is we create a class when we want to have a user defined object, which is not previously, which has not previously been defined anywhere or in any module. Right. So this is why we create a class. How do we create a class? Class is used creating the class keyword. Okay. So we use the def keyword while defining. Remember, while defining a function, we use the def keyword. So class is similar to that. Class is done using the class keyword. So we say, suppose we want to make a student class. So we say class. So is a student class a good example, or maybe a person class? Just suppose me, I'm a person, right? So I make a person class. Class person, right? That's all. Now we have multiple things in a class. So as you can see, Python is already prompting me to do some stuff. But Since it's just a blueprint, so I will just say that class person, first I'll just say pass. So it's nothing. And now, how do we define an object of a class? So, since we have a class generated, the class is person. We just say, we just name a person. Like, suppose my name is Anurag, right? Anurag is a person, is a member of the class person, and I'm now instantiated as a person. So, if we say print Anurag, print type of Anurag, so it will say, see, class person. So, Anurag is a person type, right? Now we will improve on this person class. So we have learned about person. There are some special objects in Python, initialization objects. So one of them is this def underscore underscore init. So what it does is, what init does, let me just explain to you what init does. So it's, what is init? Let me just write here. Init underscore, when you have something with double underscore, these generally refer to functions that Python has been specified by Python itself, and those are special functions. So init initializes a class, and when an object is made, an object is generated for that particular class, init, the code inside init runs by default, right? And we also see that they have showed us a self thing. So what is a self thing? We also have to define that. Self refers to the current, how do I explain this? The current instance of the class. So current instance of the class, and it is used to access the variables and methods available in the class. Right. So what is self? Basically, when we say Anurag is a person, so Anurag is being passed as a self. So now Anurag is a instance, Anurag self now refers to Anurag, which is the current instance of the class, and Anurag can access anything from self. So the parameters in init are compulsory parameters, right? So parameters in init are compulsory parameters. So because by default this code is running, so these are compulsory parameters. Parameters in init are compulsory parameters. It is a special Python function. So there are other Python functions as well. We have something like this also. We have something like post. We have something like add. We have something like subtract. So yeah, let me just set that self dot name equal to name, whatever name will pass, and self dot age equal to age. So what happens when in person I say Anurag is a person and his name I will say Anurag and I'm currently I'm 22 years old, so I'll just pass 22. Now if I print Anurag, first let me just run this. So this is defined and this is defined. And when I run Anurag, so he says Anurag is a person, Anurag is a class type person at this particular address. So a object, the object has gotten an address. So let me just see what Anurag's age is. So Anurag dot age, see my age is 22. So what is happening basically? I go into this def function. So Anurag is being passed into def function, and Anurag's age is being set as the age being passed as a parameter, right? Similarly, Anurag's name, self.name. So self here in this case is Anurag, the object, and its name is being set as the name here. So self.name, Anurag.name is being set as name, which is Anurag. So I'll just pass in. or just let me name it person1. So it will be better. Person1, person1, person1. Oh, okay, sorry. Person1 dot name, comma person1 dot age. See, Anurag, and he is 22. Right. Uh, so, what exactly is happening? When you write this line, so Python first looks up the definition of the person class. So it goes here. This is the definition of the person class. It creates a new object in memory, which is person1. So if I create person2, it will be a different one. So let me just create person2. Let's just say person2 is Bhanurag, and he is 12 years old, right? So if I just print type of person2 and just person2, just yeah. So it is at a different location, right? If I just print person1, person1. So see, they have different locations, right? So they are just assigned the locations. As soon as they are assigned locations, the init method is called automatically. So the self parameter is passed as this. This is passed as the self parameter, and then the other parameters are passed itself. And then the object stores the value of these things, and it returns the new object. Now, like person now is now a person object. Okay. And now these values are attached to the init function works is magic. We know how our function works, right? So now there is something very interesting which is called pillars of OOPS. So pillars of OOPS. So OOPS is basically in every almost all the OOP based functions, which is functions that OOP based languages, the languages that support OOPS. There are four important things. So they are inheritance, polymorphism, abstraction. And the fourth one was inheritance, polymorphism, abstraction, and mm, encapsulation. Yeah. So we'll just take a brief look at this. Then we'll go ahead and define them all. Okay. So let's go first for inheritance. Let's go for inheritance. So what is inheritance? What do you mean when you say the term inheritance? So if my father had some property, okay, and I am his son, so I will inherit those property from him, right? When I grow old, what generally happens in society, we inherit things from our elders. So what is inheriting? Inheriting is taking their, you know, when you say that he has inherited his father's looks, does that mean I have taken my father's look? No, I have similar looks to my father, which are similar. So what inheritance means is you don't generally define one single class. You define multiple classes. You define multiple objects. But sometimes one object, two or four, three objects depend on the other, or like objects have interdependability. So you can inherit the function and the values from one object to another object. There are multiple types of inheritance, which I will also show. So let's just get into it. Basically, the definition of inheritance, if I tell you, will be something like this. Uh, Something that allows a class to inherit something that allows a class to inherit attributes, which is the values, and methods, which is functions. from the other class. So don't worry, we have not yet seen how a function method works, but we'll just see that very soon. We'll first get an idea about this briefly, then we'll go back into this basics, and then we'll come back into the in depth with inheritance, polymorphism, and everything, and we'll keep on discussing things along the way. So from another class, right? So how do I explain this? Suppose we have a suppose cars. So this is a class car. Let me just pass. Now there can be different companies, right? Like we have Ferrari, we have let's come back to India. We have Tata, we have Suzuki. Like so those two make cars, but those two have their own some ideas. But the basic blueprint of a car, there's a body, there's a chassis, there are tires, there's a steering wheel, there's an engine. Those are the same things, right? So we can just have class Suzuki pass and class Maruti and pass for now. So these are three classes. So how to make Suzuki? So what do we have in class? Um, we'll just have that print. I am just a car, right? So we'll just remove the pass. Uh, we just not return. I will just return it, right? Return. I am just a car. hmm hmm So, so we just have to define a function inside the car. So we just say def uh, car. I'm just a car. Def car acknowledge or car ACK. Right. So how do we pass this thing? How do we make Suzuki realize that it's a car, it's a car, and then we also want to return that yeah, I'm also a what do we say? I'm also a Suzuki. So we just use it like this. Suzuki car. Now Suzuki also has the correct function, right? Similarly to Maruti, if you inherit car like this, Maruti now also has the correct function. So let's just see that in action. We make two things, car one equal to car. Uh, so we have Suzuki one equal to Suzuki and Maruti one equal to Maruti. Right. Now, if we just say car1 slash car1, comma, sus1 slash sus1 dot car1, comma, mar1 dot car1, let's just see what gets printed. Okay, nothing will get printed because it's returning. Let's just remove the return statement and only have the print statement. So, yeah, and then we just yeah. See, car 1 is also returning, I'm just a car. Suzuki 1 is also returning, I'm just a car. Maruti 1 is also returning, I'm just a car. But carring is not a function of Suzuki or Maruti, it's a function of the class car. So this is what inheritance is all about. Now there are multiple types of inheritance, but first let me show how can you override this method. Like you don't want Suzuki to say that I am just a car. It's a Suzuki car, right? So you can just also define car and then you can write I am I am just a I am a Suzuki car. I am a Suzuki car. So what that does is first comes to when Suzuki is created, it goes to Suzuki and it inherits the correct method. But then it says that correct method has been changed. The value of correct method has been changed. So it uses the Suzuki's own correct method. If it does not find any correct method in Suzuki, then it will use the car classes method, right? So if we see, we're not doing this. See, now Suzuki is returning, I'm a Suzuki car. Similarly, if we do this with Maruti, let's just say I'm a Maruti car. Just see what happens. See, now it is saying I'm a Maruti car. But if I remove this function and just put pass here, see, it just says I'm just a car because now the correct function is not in Maruti, it's in car. So this is how you can also override a function. You can just take it here. We have to like this. So types of polymorphism, basically there are multiple types of polymorphisms. Um, okay, let me just type them out. So there is types single inheritance, basically mm, one parent and one child class, the most basic thing, because there will be one base class, which is this car is called a base class, and then there will be one child class, which is basically Suzuki or Maruti. But there is only one parent and one child class, right? Multi-level, there is multi-level inheritance where so there will be a parent and a child, but another child inherits from the child one. So basically, this is a grandparent class, right? So if a Maruti car says that no, we want to divide by models, and says that yeah, class Omni, which is Maruti, which is a subset of Maruti, and if it just passes and just says that yeah, I just want to say that just give me the Omni equal to Omni, and then class X, it's Omni dot classic, Omni dot car acknowledgement. It says I'm just a car. No, I had not run that, so that's why it was happening. So Omni dot car goes to Maruti and says I'm a Maruti car. But if I remove this also, it will just say I'm just a car. But in Omni, we can also write like I am a Maruti car. So I'm a Omni car. You can just also keep it here. I am a Omni and Omni car. See, it now says I'm an Omni car, but what is Omni inheriting from? It's inheriting from Maruti, which in turn is inheriting from car. And car is actually a function of the car part. So if you just see that, if you just pass here and just pass here, so I'm just a car. It's now inheriting from the car class, which is a grandparent class kind of thing. So it's in multiple levels. So it's called multi-level hierarchy, right? Multi-level hierarchy is there, but a child two inherits from the child one. What else kind of hierarchy? Multiple inheritance is also there, which exactly we have seen. Multiple inheritance is basically one parent and multiple child classes, which basically is the example you've seen above that Suzuki and Maruti are both inheriting from the parent class car. So that's what is happening. Uh, yep, I think that is for code. Don't worry. Today we won't do much code heavy stuff. I'm just showing you just a basic code. I will have the because everything can't be spoon fed, right? So I will do a small project on this later, probably tomorrow or day after tomorrow. We'll do a small project on this. But for practicing, I will provide you the code. I will provide you a better version of the code, and you can find it on GitHub page, and you can run it, and you can understand. If you don't understand, you can always ask in the chat section. Let me just have a markdown here, and let me just start with encapsulation. What is encapsulation? Why is encapsulation important? So what it basically means is capsule. You know what a capsule is, right? In a capsule, there are small beads, not beads, like small chemical structures encapsulated in that, and that's a wrapper on that. So basically, in a class, data and functions come bundled together, right? Mm, like this car act, it's a function inside a car class, but name and age, these are data inside a car class, right? So data and functions come bundled together. Sorry, this property of bundling together data and functions is called encapsulation, just in general terms. So data and functions come bundled together. So this property of bundling together data and functions is called encapsulation, right? So how let us define a class. Let us define a class called not def, class called student, right? So obviously student is a person, so he will have a name and age. This is one really important keyword called super. So basically, what super does is, let me just explain, see if I can explain it in an easier way. So super, basically what super does is it calls the parent methods, like the initialization or the construction methods into the child class. So here, when we have mentioned that when we initialize this, this will run, right? But what will this correspond to? So super mentions that this super class, the person class is this super class, right? So it's a superset. So it will run the supersets init method, and then the name and the age will be passed. So basically, when we run this student thing, when the init is passed, it goes to person. The init is not done here, and then the name and age are set. Since we have a value, we just write some, let's just go ahead and write def marks, which will basically take the self, so the object, and it will just, let's see what will it return. It will just return a random, right? Random dot rand int between like 1 and 100. So one it will return a random marks between 1 and 100. Right. And what else? What else? So let's just say it is like let's just leave it like this and let's just run it once. Let's say stu is a student. Let's just keep in Anurag stu dot marks. Random is not defined. Okay, we have to import the random class. Import random. See, it gets 48. Now he gets 30. Now he gets 89. But we can also get stu dot name. So Anurag gets 43. Anurag gets 69, Anurag gets 80. So it's just generating a random marks. But you see the init method, I mean the name, age, the data, and the marks, the definition of marks, it's encapsulated in the student class. So we have now learned encapsulation and we have learned inheritance. Time to go learn a different concept called abstraction. So abstraction. So, what do you understand by the word abstraction? Like it abstracts something. What does it abstract? So, the end user or someone who is only interested in the object's data and the functions it provides, not how the data or the functions are being executed or implemented. Use this concept. So suppose I'm someone who is just interested in this part, like student. I'm not interested how the marks are generated. I'm not interested how this name is there. I just know that student, if you pass in a name and a age and then you ask them for marks, it will generate a mark. So what Python does is the complex this thing. Unless you're explicitly working on this class, this complex implementation will be hidden from you. This will be abstracted from you. This is only what you need to know. Right. If somebody tells you that yeah, there is a class student and this is the base class, you just have to set a name and a age. And when you press student dot, it will show that yeah, it has like if I say stu dot, it will say that yeah, it has name, it has age, it has marks. Like these three things you can just perform on it. So Python does not make the end user bother with how it is setting. So this is basically abstraction. Similar example, I don't think abstraction needs an example. Everything is abstracted. So this is the example of abstraction. And now we move on to polymorphism. After that, I will just explain one or two more things and then we can wrap it up for today. But I will give you the code. I will give you a really good quality code because this is a very important topic. So polymorphism, basically, what does polymorphism mean? Poly means many, right? And poly means many, and it defines that the methods in child class that are same as the methods in parent class can have a different form. How? So let's just see this thing, CarAC, right? So CarAC is a method defined in the Suzuki class, which is a child class of the car, but it has a different form, right? It returns I'm a Suzuki car. It does not return I'm just a car. So this is polymorphism. So CarAC has multiple facets. If it's used in Suzuki car, if it's used in class Suzuki, it returns I'm a Suzuki car. If it's used in Maruti, it's same as the class car. If it's used in car, it's just I'm just a car. So it has multiple facets. It has poly means multiple. So it has multiple facets, and that's how Method in child class that are same as method in parent class can have a different form or a different different return value or something like that. So that's it for today. I don't think I have anything else. Uh, let's explain something else. What you can access in a class, right? So what you can access in a class is basically there are these things called class members access, class members access. So you have a public member, a protected member, and a private member. For example, if you set if you have a class, right? If you have a class that takes a person and calculates his, uh, calculates his interest, the interest he owes based on how much. So let me just give you a code. Class tax, class person tax, and takes from the person class. Now, how do you mention that it's a private member? So tax is not calculated like this. So suppose we are not passing in tax, we're passing in amount and we're passing in time, right? And a rate. Okay, we're passing in amount, time, and a rate. We just say self dot amount equal to amount, time equal to time, and rate equal to rate, right? But now what we do def tax self return equal to amount and result of time self dot time 500, right? So what happens is if I just set it here, uh, let's just say percent tax one per tax one equal to percent tax and his name is GC. He is of age 22. He has a 1000 principal amount with 3 years and a 4% interest. Now that once we have set it, right, we don't want the rate to be changed. So what if GC somehow? So per tax, print per tax on per tax. Oh, sorry. So it is 120 rupees. Now we can change the time that, yeah, it's been 4 years since I've taken the tax. Now it's 160 rupees. But what if the person gets a hold of this rate and he says that no, I will not give 4%. I will just change it to 1% rate. See, he only has to give 40 rupees, which is unfair, right? If you are working in a bigger bank application, so if we can change the one, it's really unfair. Or if it's four, and he says that yeah, let's say per tax one per per tax one dot dot rate. I can just set the rate equal to just one. What happens is now he has to give 40. Or if he says no, it's zero point 0.1, he has to only give 4 rupees tax. That's completely unfair, right? That's completely unfair. But what if we use this thing? Now check it out. See, it's still 160. You cannot like 4. See, you cannot change it. vertex one dot rate. See, See, rate is not now not callable. Why? This double score. This double score makes it a private member. So you cannot access it outside the class. Outside the class, you can just set it once and then you cannot access it and cannot change it. So these are mainly used for sensitive variable. So what a public member is, everything here is a public member. What a protected member is, you cannot access it outside a class, but you can access it in a child class. Right? You can access it only in a child class. So public member is access anywhere, both inside and outside the class. Outside the class, access only inside a child class. But private member access only inside that particular class. How do we make protected members? We just use one underscore instead of two underscores. We use one underscore. So if I just set it as a protected member, and here we get this. This is done. This is not working. This will should not work. We say like this. Now we print it. See, age is not available here, but this will show you no issues because age has been set. So percent tax. See, percent tax age has been set. How is age getting access? So if I just print per tax one dot age. Wait a second. What does protected member mean? Does it mean? Okay, so what happens in Python is this is not enforced. So this is not very much enforced in Python, but it's a general member access rule. This is not very much enforced in Python. So this is a general rule for the class access, class member access. So for now, I'm just uploading this PDF by today, this notebook by today night. You will get a better notebook. So git add day three, git push. Sorry, git commit. Three. Have I not pushed the day to code? Yeah, I've pushed the day to code. Uh, mhm. Let me just come from here. It's easier, much easier. Yeah, let's D3. Right, I've uploaded this for now. So for today, that's all. That's it. I know it was a very short stream, but it was a very informative stream. I will do a small project tomorrow, a basic oops project. with all the concepts that we have learned. And yeah, that's it from my side today. Hi, Rishikesh. Hi, are you still there? Uh, it is a live thing. Hi, Rishikesh. Are you still in the chat? If you want to ask anything, hi, Rishikesh. If you're still in chat, you can just drop a comment. You can ask whatever you wanted to ask, or you can, if you want to interact, you can do that. I guess he's not. Uh, Downfalls of not having a second, second screen setup because you don't have one. Hopefully, my salary gets credited soon. I really desperately want a second screen. That being said, let's leave it here. Tomorrow I'll do a small mini project with all the concepts, and by tonight I will upload. By tonight or tomorrow morning, I'll upload the better code snippets in the Jupyter node for the OOPS concepts. So yeah, that's it. Have fun, guys.